Hi, Chem Peeps. Let's talk about significant figures today. Kind of a weird term, but it's important in chemistry. In chemistry, we deal with measurements and doing math with measurements, and every instrument has a degree of accuracy, and that must be reflected in the work that we do. So what is a significant figure? It's a value that is known with a degree of accuracy, i.e. meaning it probably has a marking on the instrument plus one additional estimated number. So how do you know if something is significant or not? The first rule here, any value in a measurement that is 1 through 9 is going to be significant. It's the zeros where we have to think a little bit further. There are three scenarios here. If a zero is what we call wedged, in other words, it's between two significant figures, it also becomes significant. If a zero is trailing and there's an expressed decimal point, it's going to be at the end of the number, and there's a decimal point in the value, it's going to be significant. But a zero is a placeholder, probably before the numbers, it's not going to count. So let's look at some examples to see how we can identify significant numbers. So we have some examples here. Let's look at the first number, 438.2. The 4, the 3, the 8, and the 2 are values between 1 and 9. Therefore, all four of those values in a measurement will be considered significant. So there's four significant numbers. 405. The 4 and the 5 we know are going to be significant, but what about that 0? It is actually wedged between two significant numbers. Therefore, it counts too. So there are 3. 60. Notice that there's no expressed decimal point here. This 0 is a trailing 0 at the end of the measurement, and there's no expressed decimal point. That was on purpose. It probably came from a reading from an instrument that did not have a degree of accuracy to let the 0 count. Therefore, there is only one significant number here. 1.60, the 0 is trailing. There is a decimal point expressed. All three of these count. 300, and notice there's an expressed decimal point, and that is intentional. This trailing 0 at the end is being told it's significant with this decimal being expressed. And the 0 in between is wedged between two significant numbers. So all three of these are significant. 0.05. These zeros are placeholders. They are in front of the 5, which we know counts, and therefore only the 5 counts. Likewise, in 0.8, the 0 is a placeholder, and only the 8 counts, so there is one significant number. So how do we use these numbers? Let's look at some rounding of these significant numbers. So why am I going to need to know how to round? Well, I think you're going to probably be using a calculator with your chemistry problems, and calculators read up to 9 digits, and there's not very many things that you're going to get that has that much accuracy. So we will have to round. My students typically come into my class with a rounding rule from math class. When rounding in math class, if you're dropping a number less than 5, you just leave the remaining number alone. And if you're dropping a number greater than 5, you round the remaining number. And that's true in chemistry, but it's a little more specific when you're dropping a 5. There are 3 scenarios that could happen when you drop a 5 when rounding. If you drop a 5 that's followed by the number 1 through 9, then it's just like math class, you round the remaining number. But if you drop a 5 followed by 0 or nothing, and the remaining number is even, we leave it alone. And if we drop a 5 followed by 0 or nothing, and the remaining number is odd, we round up the remaining number. So let's look at some examples of rounding significant figures. Okay, so we have 4 examples here. For all 4 examples, let's round to 3 sig figs. Just keep it consistent through all the problems. So we're going to drop and round so that our final answer has 3 sig figs. So in the first example, we're going to keep 8.13, and we're going to drop the remaining number. Looking at the first digit here, it's a 4, which is less than 5. Therefore, it's just like math class, and we leave the remaining number alone. Let's look at the second number below it here. We're going to keep 1.82. That means we're going to drop the 5 and the 0. we are dropping a 5, so you should have like a little alarm going off. Oh, this is one of those exceptions because I'm dropping a 5. Look at the rest of the situation, followed by 0, and the remaining number is even. According to our rounding rules, we're going to round this, or we're going to leave it alone, and it's 18.2. The third example, we're going to keep 1.39. We're going to drop the 5. 5 is followed by nothing, and the remaining number is odd. And so I'm going to round the 39 to 40, and our final answer is going to be 140. And be very careful to show an express decimal point here. We want that 0 to count. It's a trailer, and it will count if it has that decimal point. The last one, we're going to keep 29.7. We're going to drop 513, 5, followed by a number between 1 and 9. It's just like math class, and this is going to be 29.8. So let's apply sig figs and rounding to actual math problems that we're going to see in chemistry. Okay, so when we do math with sig figs and rounding, we have 2 rules. One rule for adding and subtracting, and one rule for multiplication and division. So let's look at adding and subtracting first. In adding and subtracting, our answer is only going to have the least number of decimal places as we began with. So looking at the example here, my first number in the problem of subtraction has 2 decimals. And my second number in the subtraction has 0 decimals. My calculator gives me 115.67, which most students would just automatically write down because the calculator said so. But if I'm going to follow my rounding in significant figures and I'm subtracting, I need to keep 0 decimals in this problem. So I'm going to drop the 6, 7, and 5 rounds to 6, and my final answer is 116. Let's look at one more example. In the problem below, we have 2 liquids. One is 45.62 milliliters, and one is 4.9 milliliters, and we're going to add because it says total. So if I add these numbers, I have 45.62 milliliters, and I have 4.9 milliliters, and I'm going to add them. I need to go back to my rule, and my rule says least number of decimals. There are 2 decimals in the first value, and there is 1 decimal in the second. So even though when I add these and my calculator gives me an answer of 50.52, I know I can keep 1 decimal. So I have to drop that 2, and I can just leave the number alone. And so my final answer is 50.5 milliliters. Okay, so let's look at multiplication and division. In multiplication and division, the rule is different as the answer has the least total amount of significant figures. So in adding and subtracting, we kept the least decimals. In multiplication and division, we keep the least total sig figs. So looking at our example, 12.0 has 3 total sig figs. 4.3 has 2 sig figs. My calculator gives me an answer of 51.6, but I must only keep 2 sig figs in my answer. I'm going to drop the 6 and round the remaining answer to 52. So let's look at the example below. It says calculate the density of an object that has a volume of 38.9 milliliters and a mass of 101.321 grams. At the beginning of chemistry, you should start talking about density, and its formula is mass over volume, and we're finding density in this problem. So let's plug in our values. Our mass is 101.321 grams, and our volume is 38.9 milliliters. Now, if you remember, I told you the reason we're rounding is because we have to carry that degree of accuracy through. When I put this into my calculator indeed fills up the entire screen with 10 digits, and I'm going to write all 10 here, but we're not going to keep them because we know that we need to follow our significant figure rules for adding and subtracting, multiplying, and dividing. So this is the answer that is given to me on the calculator. If I go back to my rule says that I can only keep the least total. So this numerator has 6 significant digits. The denominator has 3 significant digits. Therefore, I can only keep 3 in my answer. So I'm going to drop after the 0. And 4 is less than 5, so I'm not going to do any rounding. My answer is going to be 2.60, and I don't want to forget my units here because they do not divide out, grams per milliliter. So that is what significant figures and using significant figures are all about. If you want to find me on TikTok, it's the same handle, Kim's Chem Chat, and I will talk to you later.